Hello and welcome to this video comparing the effect of two different methods for the Maillard reaction. This builds on the content of the Maillard reaction video. It focused specifically on the heating process as that is the most common. The process that occurs when heating sugars and protein for the reaction was described, but it did not explain the application of an acid. The Maillard reaction is the process responsible for the brown color and aromatics that are generated by cooking. Heat is the primary method of creating Maillard products. That is seen particularly in roasting meats or baking bread, but it is not the only option. Acids also work. The process can be summarized as a reducing sugar and a protein in the presence of heat undergo a fusion process. This creates a hybrid of amino acids and sugar. This is best represented by acrylamides in coffee beans. These are responsible for some of the flavor that is characteristic of roasted coffee. The use of an acid does something a little different in the Maillard reaction. You can see that in the example of Candi sugar. This is also known as Belgian sugar and Candi syrup, which is used extensively in brewing continental ales. The process for creating Candi sugar involves dissolving sugar in a minimum of water. The sugar used in Candi sugar is a combination of fructose and glucose as two discrete sugars, as opposed to table sugar or sucrose, which is made of the same two sugars, but they are not separate. This is mixed at a roughly 1:4 ratio, with 1 part water to 4 parts sugar. Add a further teaspoon of dry malt extract or a pure amino acid like lysine if available. You then heat the sugar and water with a small amount of a culinary acid like cream of tartar, citric acid, food-grade sodium peroxide, or similar. Continue heating until it reaches 125 to 135 degrees centigrade. This is well below the ideal temperature for a Maillard reaction based on heat, but well above the minimum threshold temperature, and this is partially due to the addition of an acid. This leads to a sudden and sometimes violent reaction, which should be done in a sealed vessel. You may wonder what has happened when this occurs, and it is due to the addition of an acid. By adding an acid and heat, you break up the two sugars. These products, in combination with the amino acid in solution, produce a brown product that is not from caramelization. As a consequence, it has a unique flavor and body to it, distinct from caramel. This is all done in a liquid environment, with the sugars dissolved. After the reaction reaches a satisfactory color, you remove it from the heat. It cools into crystal sheets, which are broken into smaller parts. These shards are relatively shelf stable, which means you can keep them in a cool, dry place for an extended period. Overall, the major advantages of a heat-mediated Maillard reaction are that it functions in a dry environment. This gives you greater flexibility in application. It produces a result that is easier to set up and control, which you see in self-browning products. An acid-mediated process is able to be conducted in a liquid system, which has advantages when processing bulk or industrial quantities. It can also be achieved at a lower temperature. In contrast, there are some disadvantages. These include the use of additional reagents in acid-mediated reactions. This can add substantial cost to the process in scale. The acid reaction also starts as a liquid, which requires energy to heat. This adds further cost to the reagent, and not a product like baked bread. A dry Maillard reaction produces a dry good. This has a shorter shelf life, as you'll find with most bread. In conclusion, the two Maillard reaction approaches have certain benefits and certain arguments against them. Each is highly situational and should be used to best effect in each of its own applications. Thank you for watching this video. If you have found it useful, consider liking, sharing and subscribing. Please post any comments, questions or suggestions below.